Okay, I want to do a quick video for 6A and B because this was a topic on the last test that several people really struggled on. So let's look at how we have a couple options and then see that there's actually possibly an option that's more efficient in your mind that you should choose. But these are both set up in what's called standard form. Standard form of a linear equation is AX plus BY equals C. It's the X's plus the Y's equal to the constant. When it's set up for that, it's nicely set up to solve the system by elimination, getting rid of one variable in order to solve for the other, and then plugging back in to solve for the final variable, getting our two-part answer, our x comma y. So when looking at these, we want to see if the opposites to eliminate a variable already exist, or do we need to create the opposites? So for example, here I notice that we have a 2x and we have another 2x. Man, if we just had a negative with one of those, a positive 2x minus 2x would then eliminate and become 0. So that variable looks promising. If I look over at the y's, this is 3y's and this is 4y's. In order to eliminate that variable, I would have to multiply both rows by something in order to make something to cross out. I would have to multiply the top row by a 4 to make 12y's. I would have to multiply the bottom row by a negative 3 to make negative 12y's. It would be making two completely new rows with bigger numbers. Yes, I could do it with eliminating the y's, but do you see that the elimination of the x's is going to be a much simpler, more efficient process? All I need is to make one of these rows negative. You can choose either. You can take the whole top row and make it negative, creating a new row, negative 2x, negative 3y, equals negative 5. That is the new version, an equivalent equation to the top row, making it negative, multiplying by negative invisible 1 or subtracting it. Now we're ready to eliminate. We only look at these bottom two and we do our elimination. We see that we can now cross out the x's, eliminate the x's, and we get 4y minus 3y is 1y. And then 9 minus 5 is equal to 4. Now, when I want to plug back in to get x, I can plug back into any of the three equations. So I'm just going to choose the top one, 2x plus 3 blank equals 5. And that's where I'm going to go plug in that y equals 4 in order to solve. I'm now going to minus the 12. And I'm going to get that x equals negative 7 halves or negative 3 point. All right, so we put that answer together, x comma y for our full answer. Now, that said, I do want to go back and show you that we could have done this entire elimination process by making the bottom row negative from the get-go and still getting the same solution. So what if I had chosen to make this a negative, this a negative, this a negative? Just the whole bottom row is being subtracted. Now the x's still cross out. I get negative 1y and negative 4. 5 minus 9, negative 4. I divide by negative 1. I still get that y equals 4. I still plug y back in. Do you see what I'm saying? There's so many ways to start this. It's whichever method seems most efficient to you. All right, let's look at the next one and see which ways we could go. On the next one, I'm noticing that the y's are already opposites. Do you see how I could already cross these out? But if I eliminate the y's, do you notice that I'm going to have to add two fractions? Are you okay with that? Are you good with adding fractions? Then let's go that route because we already have the opposites. What is 2/3 plus 2/3? Remember how we add the top and keep the same denominator? Does it make sense to you to get 4/3 x? All right, now we're adding the 7/3 and the 1/3. Are you okay that not 1/3, 1 is 3/3, so 7/3 plus 3/3 is going to be 10/3. Now we're solving for x here, so I'm going to go ahead and multiply by the denominator of 3 on both sides. This is what I mean by, are you comfortable with fractions and working with fractions? Because this one, you have to know all these little parts. And then this reduces to 5/2 or 2.5. This is my x. I'm now going to go over and plug in to solve for y. So multiplying fractions, plugging in that 5/2, I'm going to get 10/6 when I do top times top over bottom times bottom. I'm going to be subtracting 10/6 from both sides. And I'm going to get y equals. Now for me to do 7/3 minus 10/6, I need a common denominator. So to make the thirds into 6, I have to multiply both the top and bottom by 2. So I create a new equivalent fraction of 14/6. Do you see where I got that? 14/6 minus 10/6 is going to be 4/6, or reduced version is 2/3. So look at this, 5/2, comma 2/3. Yikes. Do you see why some people might have needed help on number 6B? Okay, great job. Let me know if you still have any questions.